So in order to show how you can work with the raster data, now in the second icon over here, I'm going to add a raster layer, and I'm going to choose this file. That's a soak chapas file. That will be the organic carbon in soil. It's one of those variables that we can use from the database. It's from soil grids, and I just chose a small part. It doesn't cover the whole state of Chiapas. So, and this happens very commonly. If I try and do an overlay of the states and the data of where the points are and where the data is not available, so we have to be very careful on the way that we manage this information. So first of all, let's work with this raster map. I'm going to remove some of the other layers just to leave the one that we have. So I'm going to leave the background and the limits and the borders, and I'm going to change this, and the raster can be left on the lower part so we can overlay the rest on top of this. So with you can double click, and there's an option to render, but it's different. And let's say that I want colors that will allow me to choose a variable. In this case, this raster only has one layer, which is the carbon layer, but a raster could have more than one layer. And I could include, for example, the pH, and it can be chosen here. So in this case, we're going to choose the organic carbon. I'm going to invert the colors once again so that we have a similar color palette to the others. And I'm going to initially keep the original definition. And there's another option here for the histogram. In this option, you can calculate, and you can see that it looks a little bit different. Normally, raster data has many more points, so this creates a different distribution, and the values are between 40 and 60. And there are many other zero values. And these zero values can be seen in the map, and these are the values where there's no soil. Usually it will be water, like the ocean or lakes. We also have the transparency option where we can say that the zero value are unexisting data, and these values are going to be transparent. So I remove all the information that was on the water, and I can use the colors that I chose in the symbology. I can increase this contrast with the values of the histogram. We would focus like in 30, not in 0 so much. So I can go to this part, and we can choose to begin with 30. And this is going to show us a better difference between the different points. So you can see that apart from organic matter, we can see also the highest elevation. There's a higher content of organic matter, and the higher the places, and lower organic matter in the lower places. And this has a very good resolution. This map has a resolution that would be the size of the grid of 150 meters. That can also be seen here in information. It's in geographic data, so it's not going to show you the information in meters. This would be in degrees. But if you would transform these, it would give you 150 meters. So it's a very good resolution for a map for the whole state. And you can see the level of detail that this has. We can also compare the carbon soil content with the one that we have depending on the type of soil. So this can give you a better idea of the differences between the vectorial data and the raster type of data. The raster data are always in this organized grids, while the vector data can be represented in irregular shapes. So you require different shapes to represent the same information. So this raster file has a better representation of the information when you wish to obtain the information about the whole area, from the whole area. And you can see that there are many differences here between one and the other. The variability of carbon has different scales. And in this, for example, in this place, in the values of the polygon, there were very high values. It had dark colors, and the value of organic matter is here is in 2.3. But if you see the raster data, the truth is that this part has less than organic matter than this part. So those differences can be perceived with this type of map. And it can also be used to compare and understand what information can be more accurate, where's more saturation or less, depending on the analysis that you want to carry out.